Okay, so you should have this half sheet from your folder. So yesterday we looked at writing hypotheses and defining parameters, all of that. So that's kind of the beginning of doing a hypothesis test. This making the decision is kind of the end of it. So we're going to look at each end because the middle part is exactly what you just took the quiz over from Chapter 7. So that middle part we've kind of already done. We're just doing the two bookends that will come before and after. So this Hugo and Polly, this was from yesterday's problem set that we just looked at. So if you look at this last question, this is the manager of Bigwig Executive Hairstyles, Hugo Brandt, has advertised that 90% of the firm's customers are satisfied with the company's services. Polly is a consumer activist, and she feels this is an exaggerated statement that might require legal action. Okay? So this is the Hugo and Polly that we're referring to in today's notes. Okay? So that's what we're kind of going back to. So it's Hugo and Polly. Hugo says that 90% of customers are satisfied. Okay? Assuming this is true, they want us to find the mean and standard deviation for this situation. So the mean is just the proportion that he claims to be true. So this 90%. The standard deviation we have to calculate based on our sample size and based on the value of P. So this is that formula that we use. It's on your formula sheet right here. Okay? So we're using this formula to calculate the standard deviation. So here P is 0.9. And then 1 minus P would be 0.1. Our sample size is 150. So we just plug all of that into the formula. So we get 0.0245. This we've done before. This is what we were doing in the last chapter, in Chapter 7. So that's mean and standard deviation. From there, we should be able to sketch a graph. So we should be able to sketch what a normal distribution for this situation would look like. So if I were to sketch this out, I want to draw this kind of big because we're going to label some stuff on here. So right in the middle goes what number? 0.9. Good. Now we're going to go back to first semester when we first started talking about normal model, and we said you can go 3 standard deviations each direction. And we learned how to label those standard deviations with the values associated with it. Remember this? We talked about the empirical rule, the 68, 95, 99.7. We're going to go back and label this just to keep that in front of you. You wouldn't have to do this every time. Just realize we're just doing it to refresh your memory on how to do that. So if I label these, this is 0.9245, 0.949, and 0.9735. Here we have 0.8755, 0.851, and 0.8265. So just as a refresher for your memory, that's how we would label it if we wanted to label the whole thing. So Polly thinks that Hugo has exaggerated the numbers. She does not believe that 90% of the customers are actually satisfied. So, if we are going to test this claim, we would say this up here is the claim. This is H sub O. And we want to know, what does Polly think about this? So what type of inequality are we going to write for H sub A? Less than. Because she thinks it's an exaggerated view, so she thinks it's actually less than what he claims. So this would be called a left tail test because we're looking left of this number. So it would be a one-tailed left tail test. So Polly then went out and did her own random sample of 150 customers, and she found 132 of those 150 were satisfied with the salon. So we use P hat to show this is from a sample. So if we say P, we're talking about population. P hat means the sample. So you need to kind of get used to that notation. So here, P hat will be the 132 out of 150. So in her sample, that's what she found to be true. So if we divide that out, we get 0.88. So our job is to figure out, does this getting a 0.88 mean that we don't think that 0.99 is accurate? Is this number far enough away from 0.9, what we think is the mean, to say there's a problem here? So the way we do this is we calculate a z-score based on this sample information. Okay, so we found that our sample, our P hat, was 0.88. So we're going to use that value to see what is the probability of getting something that is less than this. So if we think about it up here on our table, we claim that this is the mean. We want to know what's the probability of getting this 0.88 or something less, because we're doing a less than. So that's what we're finding, is how likely is this to happen? So that's why this 0.88 is our value that we're looking at to calculate the z-score. So this is our value, this is our mean, and we already have our standard deviation up here that we calculated. So I can find a z-score by doing our value, this 0.88, minus the mean, which was 0.9, over the standard deviation, which we already calculated up here to be 0.0245. I'll get a z-score of negative 0.82. Which makes sense because it was right here before that first standard deviation. It was in between here but closer to here. So that kind of makes sense for our drawing. So we want to look this up from the table and get our probability. Maybe look that up yet. 0.2061. So as you can see, this is stuff we've done. This is not new kind of math. We're just doing the same thing that we've done in previous problems. So this value, this probability we come up with, we refer to that as a p-value. It's the probability of getting this from a sample or something farther away from the mean. So it's whatever direction our alternate hypothesis is. It's that direction from this value. So since we had a less than, it's what's the probability shaded less than this. So that's our p-value. So one of the things, as you've seen, when we calculate a value, we need to know what does that value mean. So our interpretation of the p-value. Now, this right here, I have never seen a multiple choice part of an AP exam that does not have a question about interpreting p-value. That will show up. So that means it will be on the quiz. It will be on your test. You will be seeing a question about interpreting the p-value. I will guarantee that. Make sure you know this part. Okay? So whatever you need to do to draw attention to it, you need to know this. So what this says is if the null hypothesis is true. So assuming the null hypothesis of 0.9. So that's what we said we thought was true. That's what Hugo's claim is. So if Hugo is right, and this is true, the probability of observing a sample proportion of 0.88, which is what Polly got, or more extreme, so here, or less, by random chance is, and that's our p-value. So for those of us who are visual people, what it's saying is if this is really the middle, the probability of being here or less is that p-value. It's that probability that we found. As we said, if this is true, the probability of here or less is 0.2061. Okay, so it's just explaining that picture. Okay, so if you think of it in those terms, that's all you're doing. So this often is a multiple choice question. Sometimes it will show up on the free response, explain what this p-value means in context. But often it's a multiple choice, and they'll have it written all sorts of different ways, and you have to figure out which one is correct. So you need to know that p-value explanation. Okay, so what does the p-value do? It measures the strength of the evidence against HO. So if you think of this, I often think when we get to hypothesis testing, think of it like a courtroom situation. So this is the prosecution. How strong is their case? Okay, so it's how much evidence do they have against the defendant? That's what you're looking for here. It's how strong is the case that they are not an honest person or whatever it is they're accused of. So here, Polly is accusing Hugo of inflating this number. So this is saying how strong is the evidence that he inflated the number. Okay, that's what the p-value is measuring. So the smaller the p-value, the more evidence against HO. At first, that sounds kind of backwards. Smaller numbers shouldn't be more evidence, but it makes it less likely to occur. Think of it in that way. If it's a small p-value, then the probability of getting out here, just think if we move this number farther away, if this line were way over here, then it's really going to be a small percentage of the time that you get something out here if this is true. If we're getting something way out here, then 90% is probably not true. So that's strong evidence that 90% is not correct. Okay, if we're getting something way outside, then we're saying our number was probably not truly the middle. Because if we're gathering a sample from a population, our sample value should be close to the population. If we're getting samples that are not close, we're going to say our population is not what we thought it was, because this sample should represent what our population looks like. Did that answer your question?
Yeah.
Okay. anybody else questions on that? Okay. Look at the back side. So, with regard to p-values, when do you reject HO? That's going to be our big question is, are we rejecting HO? So, we reject HO when the p-value is really small. So what question does that make you want to ask?
How small is small?
There you go. How small is too small? How do I know? So what we're going to do is we're going to compare our p-value notice to be less than what we're going to call alpha. And normally I won't write it out like that. I'll use the Greek letter alpha. But just so you know that's what we're doing, we'll write it out this time. So we compare the p-value that we calculate with a value that's alpha. And alpha will normally be given to you. And I'll explain what to do if it's not. But most of the time they're going to tell you what that is in the problem. And so you will have that to compare to see, is it less than alpha, is it not? So if our data is declared statistically significant, that means we rejected HO. Due to a small p-value. So it's when we have a strong case, when our evidence shows clearly that what we thought was true is not true. Okay, so we have strong evidence. Then we call that statistically significant. We say the difference between the two was statistically significant. In a courtroom, it's beyond reasonable doubt. Okay, you've heard that. So it's where we wouldn't think this is true because this is so far different. Okay, if we think back to the example that I used yesterday with the percent of students that have part-time jobs, if I think that the percent is 68%, but I keep getting samples with 32%, I'm probably going to think 68% is not correct. Okay, because this is so far different that it's not just due to random chance. So, what is an alpha level? So if we're going to compare to alpha, we need to know something about alpha. So the alpha level, and we'll call that just the Greek letter alpha is what we usually use. So it is the cutoff for a rare event. So anything beyond that alpha level, we're going to say this is not normal to get this value. So it's at what point does it become statistically significant? That's the alpha level. It's what amount are we willing to accept? It's what it looks like. It looks like the Jesus fish. I agree. Oh, sorry. Yeah. So, common alpha levels. The most commonly used is 0.05. That is the most common. If an alpha level is not given to you in the problem, this is the one you use. So this is kind of the most common and the default. If there's not one given, this is the one you use. Other ones that we use fairly often, probably the next most common is 10% or 0.1 or 0.01. Every once in a while, you'll see one at 2% or something like that, but that's pretty uncommon. These three are the most commonly used alpha levels. The alpha level is also known as the level of significance. So sometimes they will say the level of significance is this, and you need to recognize that's just the alpha level. Okay, so let's look at how we're going to do this. So here we have a p-value and an alpha. And we're going to compare these and decide what is our decision going to be. So whenever we do one of these, I normally write p-value and alpha, and then I'll put a comparison in here, less than, greater than, whichever way it goes. And that is your justification for your decision. So when it says tell why, that's what it's looking for, is that comparison between p-value and alpha. So here we have a p-value of 0.051 and an alpha of 0.05. So what type of inequality goes here? Greater than. It's barely greater than, but it's greater than. So up here we learned if p-value is less than alpha, that's when we reject. So here it's not less than, it's greater than. So here we do not reject. HO. Okay, please hear me say this, because I do not want anybody to miss this on the quiz or test. You never, ever, ever accept HO. Do not do that. It'll be wrong every time. You either reject HO or you do not reject HO. Those are the only two possible conclusions. You cannot do anything other than reject HO or do not reject HO. Okay? It's kind of like whenever you get a verdict in a courtroom, they're either guilty or not guilty. It's not guilty or innocent, it's guilty or not guilty. Same kind of thing. We reject or we do not reject, but that's it. Okay? So be careful with your wording. Okay, part B. We have p-value and alpha. So our p-value is 0.024. Alpha is 0.05. So less than or greater than? Less than. So if it's less than, that's when we reject. Then you would carry it out to more decimal places. What?
Are the fish things that we're drawing supposed to be like the A that's like right above?
Yeah, they're kind of. It's just that font makes it not look necessarily like. Yeah, they're supposed to look like the Jesus fish. That's what they're supposed to look like. Okay, so part C. So now we have a different alpha level. It's 0.01. So we're comparing 0.024 to 0.01. Greater than. So what's my conclusion? Do not reject. Good.
We neither reject or accept.
You have to do one. Can't be wishy-washy. Okay. Now we get a p-value of 10%, so 0.1. So now we've got a p-value less than. So what's my decision? Reject.
Do not accept.
You're going to be that one that tries to be funny. You're going to miss your points.
I'm going to do that on the AP test.
Oh, please don't do that. Please do not do that. I will look back and cry all over your test. So are we good with those? Are you seeing how this works? Okay, so let's look at the second one. This is a survey of student habits and attitudes. SSHA is a psychological test that measures students' attitudes toward school and study habits. Scores range from 0 to 200. The national average score for U.S. college students is 115. A college professor suspects that older students have better attitudes toward school. So she plans to administer a survey to a random sample of students at her college who are at least 30 years of age. We need to come up with a null and alternative hypothesis for this test. So, first of all, we need to decide, are we talking about means or proportions? Means. How do you know? Yeah, because it says an average score. So that tells me it's a mean. So how am I going to define this parameter? The true mean SSHA score of college students over 30. Because we're looking at the over 30 crowd. Just wait till next year. You'll go to class and there'll be that one person and they're just taking like one college class and you're like, you have so much time to dedicate to this one class. You're ruining our curve. It's like, oh my goodness. Yeah, there'll be that one person. Okay. So HO is always the value equals. So what do we think is the true average? 115. Good. And then HA, we're still using mu and 115. Now we need an inequality. Right. Because we're going to say they think there are better attitudes, which means a higher score. Okay. So now, part B. After administering the survey, the professor finds the sample mean, that's supposed to be mean, not min. Sample mean, SSHA score was 125.7, which yielded a p-value of 0.0102. Interpret the p-value in the context of this study. So we're just writing out that interpretation. So we're going to say if the national average SSHA score is really 115. So we're saying if HO is true, is basically what we're saying there. The probability of obtaining a sample of 125.7 or higher. Since it was greater than, we're going to say that or higher. If it were less than, we would say or less. Is, and then our p-value is just going to go in there. So if HO is true, the probability of getting what we have in our sample, or higher or lower, is the p-value. That's how you're going to write it out each time. You okay? All right, so now we're going to make a decision. So if alpha equals 0.05, what would the decision be? So our p-value, 0.0102, we're going to compare that to alpha of 0.05. And this value is less than alpha. So what is my decision? There you go. If we're using this alpha level, then the p-value, which is 0.0102, compare that to alpha of 0.01, now the p-value is greater than alpha. So we would not reject. Questions on that? Is this making sense to you? It's a lot of wording. It's a lot of how do you phrase things. And you'll get there as you practice it more. So you should have time to finish your problem set during class so you don't have to take anything home over the weekend. So this will go on page 51, and then your problem set on page 52. So go ahead and attach that and finish it, and then you don't have homework. Yep.
So